Okay, so in this question, we have been given that a particle P moves along the x-axis. The velocity of P is v meters per second at any given time, and it is given that v of t is 4 plus 4t minus 3t squared for t between 0 to 3. When t is 0, particle is at the origin. So what we have to do is we have to find out the time when particle reaches its maximum velocity. So obviously, you know that its maximum velocity, meaning you're optimizing the velocity expression. So you just do dv by dt with respect to, so you differentiate this and equate to 0. So dv by dt is going to be 4 plus the derivative of 4 is 0, derivative of 4t is 4, and derivative of minus 3t squared is minus 60. So what you get is you basically get the value of this to 0. So you get t as 4 upon 6, which is nothing but t as 2/3. So that's your time when it reaches the maximum velocity. And obviously you can verify by second derivative. So d square v by dt square, when you do, you get -6, which is negative, hence it is a maximum. Also it's a quadratic, it's a sad phase graph, you can see, hence it is a maximum. So the answer for the first part is t equals to 2/3. Show that the distance of P from origin at this time is 88 and 2 by and 27, 88 by 27. So obviously what you do is, like, since you have been given that, okay, now if I look at a function here, if I put, let's say, t as 0, it is something like this. It is maximum at 2/3. So this is a 2/3 is the line of symmetry here. And so to get the distance, you just integrate between 0 to 2/3 the expressions of 4 plus 4t minus 3t squared. And if I integrate this, it'll be obviously 4t plus 4t square over 2 minus 3t cube over 3, and you put the limit 0 to 2/3. So this is going to become 4t plus 2t squared minus t cube, and then you put 2/3 and 0. So if you put 2/3 here, it becomes 8 by 3 plus 2 times 4 by 9. So it'll become 8 by 9 and minus 8 by 27. So minus 8 by 27. And if I take LCM and simplify this, we are going to get this as 88 over 27. Okay, so the next part they say is sketch the graph of velocity against time, clearly showing the point of intersections with axes. So we already have got the, like, your y-intercept is obviously 4. We got this coordinates 2/3. It has got certain maxima, and then it is going to be like here. So if you can find out this root, obviously you just equate minus 3t square plus 4t plus 4 equals to 0. So if I factorize it, 3t square minus 4t minus 4 is 0. Split the middle term. So product of the numbers is -12 and sum is -4. So 3t square -60 positive 2t minus 4 equals to 0. You're going to take 3t common, and you get t minus 2 plus 2 common, t minus 2 equals to 0. So you get t minus 2 and 3t plus 2 equals to 0. So you're going to get t as 2 or t as -2 by 3. T can't be -2 by 3. So this point is basically t as 2. All right. The next part is that they're asking is find out the distance traveled by the particle at this stage. So between, like, this entire expression, so find out the total distance. Now see here, part of the graph is going below x-axis. So remember that you're going to just find out this area. If you integrate the velocity function from here to here, you will not get distance, you'll get displacement. So if I integrate blindly, 4 plus 4t minus 3t squared, This is not going to give us, let's say 0 to 3. If I do, this is not going to give us the exact answer, because part of the answer will cancel. Indeed, like you'll get only certain part of the area, because this part will be negative, this part is positive, so it's going to get cancelled some part. So what you do here is you integrate from 0 to 2, and then you integrate the second this thing, 4 plus 4t minus 3t square, from 2 to 3. So from 2 to 3 you integrate this answer. We already have the integration, 4t plus 2t square minus t cube. So you put the limits here, 2 and 0. If you put the limits, it's 8 plus, this is 8 minus 8. So this get cancelled. So the first part is 8, plus we still are left with this. So now you plug in TS3 here. So it'll become 4t plus 4t plus 2t squared minus t cube. If I now find out this value, 2 to 3, plug in 3 here. So it becomes 24. 4 threes are, sorry, this is 4 threes are 12. Plus this is 9 times 2 is 18, and minus 27. So minus 27. So this is going to become 30 minus 27. So this is basically 3. So this answer is going to be 3. If you find the value of this, will be 3 minus 8. Since we already have got the answer for previous one, so it's negative 5. So overall, this area we got is 8, and this area we're getting is negative 5. Obviously, area can't be negative 5, so you take it as positive. So 8 plus 5, which is in total, we got as the total distance travel is basically 13. All right, so this is basically we have to prove that the derivative of nth derivative of x square e to the power n is given by x square plus 2nx plus n times n minus 1 e to the power x. Okay, so what we do is basically start with n equals to 1. So the first derivative, when I find out, let's say first derivative will be d by dx of x square e to the power x. Manually, when you apply product rule, for n equals to 1 I'm doing. So if I do that, I get x squared times e to the power x plus e to the power x times 2x. So you get e to the power x, x squared plus 2x. That's the derivative according to the product rule. Now, according to the formula, if I plug in n as a 1 out here, you get d1 dx1 of x squared e to the power y. I'm just plugging n as 1 everywhere. It is x squared plus 2 times x plus 0 times e to the power x, which is x squared plus 2x e to the power x, which is pretty much the same thing as n equals to 1 derivative. So we got the first derivative same, so we can assume that the kth derivative is also same. So dk over dxk y, or you can say this is the assumption. So x square e to the power x will be here x square plus 2kx plus k times k minus 1 times e to the power x. Now, if this is true, now this is assumption that n equals to k is true. Now, if this is true, then my k plus 1th derivative, x squared e to the power x, I should get as what I should get, or you can say to prove, is if you replace k with n with k plus 1 basically. So it should be e to the power x as it is, here, and x squared plus 2 times k plus 1 times x plus k plus 1 times k plus 1 minus 1. So plus 1 and minus 1 cancels, and you get e to the power x, x squared plus 2, k plus 1 x plus k times k plus 1. This is what I have to prove. This is what I should get. Now, remember that if I differentiate the kth derivative, I get the k plus 1th derivative. So you have to basically differentiate this. And if you differentiate this, you can simply see the product rule being applied here. So what do we do is you apply product rule. So the k plus 1th derivative, I'm just writing y here. It'll be by product rule. So e to the power x as it is into derivative of all of this. So x squared derivative will be 2x. 2kx derivative will be only 2k. And this derivative will be 0. So that's nothing plus x squared plus 2kx plus k times k minus 1 as it is into derivative e raised to x. So u v dash plus v u dash. Now if I take e to the power x common, I ideally should get what I want here. So okay, so if you look at here, I've got x squared plus 2kx. Then you've got even 2x here, so 2x here. Then I've got 2k here, so plus 2k. Plus, if you open this bracket, I get k squared minus k. And if you simplify this, I get e to the power x, x squared as it is. Now 2kx plus 2, if I remove, factorize it properly, I get 2 times k plus 1x. You get k squared plus k because 2k minus k is k. And if you take k common from there, you get k times k plus 1. So you can see I have got exactly the same thing that I wanted here. So since n equals to 1 is true, n equals to k is true, n equals to k plus 1 is true, hence this is going to be the derivative that will be true for all positive integers. So just wanted to reiterate, like, that for b part, you're expressing this function in terms of polynomial power series up to x to the power 4. So now remember that the Maclaurin series for any function is f of 0 plus x times f dash 0 plus x square over 2 factorial f double dash 0 plus x cube over 3 factorial f triple dash 0 plus x to the power 4 factorial f fourth derivative, and you plug in x as 0. So look, here we already got a formula for the derivative, okay? So since we, now when they say hen, like, hence write down the, series, it simply means that hence or otherwise is simply here, because we know the series for, like, e to the power x. So it is directly can be taken from data booklet, and then you multiply that series by x, you straight away get the answer. So first I'm going to, for this part, I'm going to just take the, let's say the series that exists, which is x squared e to the power x. Now, the Maclaurin series for e to the power x, when we look at the data booklet, and you can just read it from the data booklet. When you take the series for e to the power x, we have got the series for e to the power x in the data booklet as 1 plus x over 1 factorial x squared over 2 factorial and so on. So just open it up. Since they wanted only till x to the power 4, we have got x squared x cube over 1 factorial x to the power 4 over 2 factorial, and remaining terms x raised to 5 over 3 factorial, and so on. So remaining terms I'm not looking at because they just have asked for until x to the power 4. So what we have got is until x to the power 4, the expansion is this. X squared x cube over 1 factorial x to the power 4 over 2 factorial. Now it'll be interesting to actually look at the derivative also. So first what I'm going to do is I'm going to find out the first derivative. Let's say f of 0 is obviously like 0. You can see that. So this value I'm just going to write with green color. So f of 0 is 0 plus x times f dash 0. So we did already the first derivative, but you plug in n as 1, I get the first derivative as, which is x squared plus 2x times e to the power x. So here if I plug in x as 0, you are going to get the answer as 0 again. So f dash 0 is basically 0. Now, plug in n as 2 here to get the second derivative. So if I do the second derivative, you get x squared plus 4x plus, if I take n as 2, will be 2 times 1, which is 2 itself, and times e to the power x. Now you plug in x as 0, so it'll be 2 times e to the power 0, which is 2. So likewise, if you go on to do this, you get the second derivative as 2. Third derivative will be, let's say, if I find out the third derivative, now plug in ns3 here. So d cube y over dx cube, it is equals to, what we get is x squared plus 6x, and you get plus, here you plug ns3, so 3 times 2, which is 6, and times e to the power x. Now you plug in x as 0 here, you get 6 e to the power 0, so you get answer as 6. So likewise, you can keep doing that, and if you substitute here, so you get x times 0, x squared over 2 factorial times f second derivative is, you can see it is 2. So that's why this can cancel, and you can see that I get x squared over 1, which is clearly evident here. Then you get x cubed over 3 factorials, x3 factorial times the second derivative, which is 6. So 6. So 6 times 3 factorial is 1. If you cancel out, so that also is 1 factorial, or you can say 1, and so on. So if you keep doing that, you get the series for this as it is. So that's your x squared plus x cubed by 1 plus x to the power 4 by 2 factorial. Are we clear, guys? So what we have got here is that we have to determine the limit for this function when it is x tending to 0, x squared e to the power x minus x squared e to the power x squared to the power 3 over x to the power 9. So ideally, you could have done like by plugging x as 0 and 0, you can see that you can apply like L'Hopital rule. So since the functions of the form 0 by 0 or infinity by infinity formats, since it is in this form, I could apply L'Hopital, but it's easier when you have got something already in, like, to do the make the calculations easier. So if you have got a limit x tending to 0, we get x squared e to the power x minus x squared whole to the power 3 over x to the power 9, and so on. So x squared e to the power x, we already got the expansion as x squared plus x cubed plus x to the power 4 over 2 minus x squared. I just put these values because, see, obviously the series continues, and whole to the power 3 upon x to the power 9. X squared and x squared get cancelled, and any formula if you apply, obviously, like, this will be x to the power 9 term. The first term will contain x to the power 9, and the remaining will be a higher power that contain x, right? So you take x to the power 9 here. Now if you take x to the power 9 common, if you take x to the power 9 common from the rest of the stuff, it'll be like 1 plus the term that contains x, so x containing stuff, upon x to the power 9. So this get cancelled, and if you plug in x as 0 here, rest of the things become 0. So the answer is 1. So that's how you do this particular question.